Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about future of power generation as we are using it right now. So what exactly is the problem? Well, problem is that world needs power, meaning we need X amount of power. And there's a problem. We also need growing amount of, meaning X square will be the future. So if a small town could be run at 100 megawatt power plant, now it needs 200. And tomorrow it's going to need 300. So that creates a scenario where you need lots of power and increasing amount of it. Now that creates another current scenario, that is our current methods are making too much CO2, and that's very bad. Now there are people who say like global warming is not real. Okay, no problem. Let's say you do not agree with that. Awesome, no problem. I don't care. Here's it. You do care about nation's independence, meaning let's say you're a citizen of a country, for example India. You do not want to live in India if there is a scenario where Russia can like, hey, we can cut your gas supply, we can cut your oil supply, and that will literally wreck your economy. You do not want to be there. You do not like to want to be like Sri Lanka. You do not want to be like China, where it actually has to buy coal from Australia. Let that sink in. It has to buy coal from Australia. Let that sink in. And that's the whole problem. If you're running a nation, you want the nation to be independent, where it's like, bro, I got this. You want to be like Denmark, where it's like, dude, we had enough solar power, enough offshore wind system. Again, population is also small, some hydro and all this and all that, and also with good interconnects between some nations. So they have the luxury of like, bro, we got this, we are sorted. You want to be like that. You do not want to be like, okay, if Russia is trolling, we get screwed. If Australia is trolling, we get screwed. If Sri Lanka is trolling, we get, well, you get the point. You want nations to be energy independent. If you're not energy independent, you are dependent. You may be independent, but you are still dependent. So that creates a very serious scenario where it's in everyone's best interest to become renewable dependent as quickly as possible, because that's not going to run out. Now, we also must reduce CO2 output, because again, I generally don't get the people who are like, global warming is not real. I'm like, dude, I'm physically seeing its footprints now. So, but okay. And if we do not reduce it right now, we will become fossil. If we do not stop using fossil fuel, we will become fossils. Like, these are real and these are happening right now, and these are unprecedented level of damage. It's not something, oh, back in the days. No, this never happened. Like, this did not happen in thousands of years of recorded human history. It's like, that's how significant it is. Like, the lake beds, some of the lake beds that are drying right now, that's like, dude, no human has touched this land like for thousands of years. So it is a very serious problem, and energy produces the majority of CO2. So we have to take care of that puppy. So what about thermal plants? Right now, majority of our energy comes from thermal plant, be it coal, be it natural gas, be it whatever else. So generally, majority of our energy comes from thermal plants. Now, thermal plants are generally steam-based system. Now, steam system does work. It's a known technology. It's a tested technology. It does have very good uptime, meaning if you start it, it will keep going and going and going, and you only have to shut it down only a few years just as a safety precaution for maintenance. But it's very good, but it is bad. Now, there are side effects of this sort of plant we did not realize in short term. Long term, now we are like, dude, these are destructive, because it wastes fresh water, a lot of fresh water. Now, why does it waste? Well, because it's not using a one phase system. It is using phase change system, meaning it takes a liquid, boils it into, well, steam, and then steam drives the turbine, but steam still has not lost all of its energy. If it had done that, it would have phase change into liquid. It does not do that. So that steam has to condense. Now they send it to cooling towers. That giant stack that you see, that's the cooling tower. Now here's the deal. Many times you would have noticed there are steam coming out of it. That should not happen, and that's the problem. We are using what we call evaporative cooling, meaning we are letting water evaporate. Now, that may not sound an issue, a little bit of water. Again, people thought that when they built power plants, we thought that that's not going to be an issue. We were like, dude, we are taking water from river. What's going to happen? The river is not going to run dry. We are taking water from underground reservoir, and nothing's going to happen. But here's the deal. Right now, at this point in time, majority of thermal power plants are like, yeah, we're going to run out of water very soon. Like very soon. Many thermal power plants in India had to be shut down. Same happened in Germany, same happened in France also, where they're like, yeah, we drained the lake dry. Yeah, underground water, yeah, that's gone. So this sort of long-term use is flat out unsustainable. Now, unless you are next to a sea and you are running a desalination plant, nothing other than that can keep open cycle steam system running forever. Like, flat out, it burns too much water away. It's just like, let it evaporate, and these are gigaliters of water that is being evaporated per day. So over time, nothing can replenish it. So, and not to mention it, recent heat wave in Europe exposed this vulnerability where it's like heat wave is happening. People want to turn on their AC. Here's the deal. They want more power, but there is not enough water body. Consequence, power plants had to shut it down. When people wanted the most amount of energy, power plant had to shut down. Again, you may not care about environment, you may not even care about river or things of that nature, but you do care about the fact that you do not have power. So that's a very serious scenario. We have to close the loop, meaning we have to shift away from evaporative cooling. What way we do that, that's up to us, that's up to engineering, that's up to cost economics, but we have to do it. It's not optional anymore. It is something that we have to do, or wait long enough where it's like, okay, this power plant is shut down, okay, this power plant is shut down, okay, this power plant is shut down also. This is happening. We got just a small taste of it, and it's not looking good. So that's we have to do. Or we have to use jet engines. Now jet engines are not designed for like that major scale power, but there are like a lot of jet companies that are become like be from General Electric and other companies that are becoming more popular specifically because of natural gas. And jet engines do have the benefit that they work on one phase, meaning there is no water that they are consuming. They still have some water requirement, but compared to thermal plants, their water requirement is negligible. So if you're running on natural gas, that could be a short-term solution. Now, what is the ideal solution? Ideal solution is that we have to move to supercritical CO2 turbines for the future. Now, that technology is here. It's real. It's just working on the making the scale larger. Like this turbine is 10 megawatt now. Like wait a minute, 10 megawatt cannot fit in this. Have you ever seen a jet engine's energy density? It is on the same level, and the shaft is very thick. So it's running on single phase. It does not change its phase. Now again, if people design it properly, and heat rejection system, meaning waste heat is dumped into the atmosphere directly, heat atmosphere, no water evaporating, that will solve the problem. And there is another benefit. This system is far more efficient because it's not changing phase. It's 10% to 20% more efficient compared to steam system. So even if your power requirement is going up, your CO2 footprint will remain exactly the same. You will get more power out of it. And if you're not evaporating gigatons of water every year, okay, that's another advantage. That means your power plant can run even in a driest place without ever worrying out, and you do not have to worry. It's like, hey dude, there is a drought coming, and it's like power plant shut down. No, power plant is like, I got you back. I will take care of the situation. So we have to do it. It's no longer optional. The recent drought in China and Europe kind of exposed this vulnerability to a large scale. We knew this, like more than enough engineers were like, dude, I think this is a bad system, but nobody was taking it seriously. But right now it's like, yeah, we kind of get it. So what about nuclear power? Everybody's like, France, nuclear power, France, nuclear power. Well, let's be realistic. Fusion, basically using helium and deuterium and tritium, all that jazz, to get energy out of it. That's not happening anytime soon. Let's be very real. It's not happening. I was a kid when I used to hear this sort of system in like Discovery Channel and all that jazz. It's not happening anytime soon. My current understanding and current math is flat out it's not happening within 30 years. Flat out. I can bet money on it. It's not happening. Break even, we have not achieved it. And we need multiple X of break even in order to make enough energy. And not to mention, even if we can somehow achieve it, somehow it has to be cost effective in order to build it. Like your country is not going to go bankrupt. It's like, this amazing reactor is amazing. It just requires few $1 trillion to make it. Nobody's going to make it. It's like, where the heck you going to get the loan out of it? So fusion is not happening anytime soon. Now, I was like very against fusion at this point in time, simply because we are running out of time and money. Neither of these things have refund values. So we have to use our time very wisely. Like think of this, like you're going to hospital because you're losing blood. Doctor is not, I think you should really look into your, your weight loss. And like, no, take care of the blood first. Like, time is running low. So we have to be realistic at this point in time. Again, once we have sorted the system would be amazing. It will allow our civilization to expand. But right now, not good tool at this point in time. What about fission? It does work. It's a known technology. Everybody forgets about it. It's too goddamn expensive. Meaning, if I tell you, hey, give me a 1 gigawatt hour, 1 gigawatt solar farm, it's cheap. Like every government, including Indian government, can just like, yeah, here you go. We are doing it, by the way. We are doing it. Literally, every day India is getting few megawatts of solar farm added to it. That's how quickly we are doing it. But yes, the fission is very, very expensive. And it's also slow, meaning it could take minimum of 10 years. Let that sink in. Meaning you start a project, 10 years later, the project is completed. So that's a very long term, and many times you do not have the fuel supply. You still have dependency on some other country. For example, India has a lot of thorium reserves. So India was like, we're gonna build thorium reactor. That should have been, the trial experimental reactor should have been done by 2012. Let that sink in. It is 2022. So that's the whole reason. That's why fission is also not something that you can trust very long term. It's too expensive to add new ones, and very slow even if you want to add ones. and it does need large fresh water. This happened recently to France, where the drought was like, drying out rivers, and the government was like, dude, stop dumping giantly heated water into the system, like basically hot water temperature. Now again, to reduce hot water temperature, you have to cool down the reactor. To cool down the reactor, meaning you have to remove the fission, reduce the fission rate. Output, your energy goes down when you need it the most. So then government was stuck in a situation whether we boil off the river, whatever little river is remaining, boil off the river or shut down the power. Again, it's not as independent as people thought. Like, it looks independent, but here's this, poof. So it does need large fresh water, same problem as thermal plant. So it's not long-term solution. And not to mention, unless you build it next to a sea and have a giant desalination plant, it's flat out not sustainable. And it does not tolerate mistake. Like, yeah, I can get it, like you can build some system that can take care of nuclear waste without an issue. I can get it, you can have a plant that does not spew radioactive waste everywhere. But here's the, those things are assuming that you do not make mistake. We humans, we make mistake. And this puppy does not tolerate oops. It does not tolerate oops. It's like, no, you shall not do oops. And here's the deal, I know humans, we make oops a lot. So realistically, that's why nuclear power is not something that you're going to see a lot more in the future. In short term, again, government may like, okay, this crisis showed us that we have to go nuclear, then start it 4 years from now when the world economy has changed. It's like, yeah, let's shut it down. Has happened in the past. So what about solar? Now, solar is the best success story at this point in time. Now, again, I have different perspective on solar simply because I live very close to equator. People who are living more in the upper regions of the earth, they are not getting the same oomph out of it as I am getting. So in India and even worldwide, even if you take that into consideration, it's the fastest growing renewable, flat out. Which renewable is being installed at this point in time? Solar. Like, you just close your eyes, open your eyes, few kilowatts of solar would have been added, no matter which country you are in. It's growing exponentially fast. And it does allow sort of predictable power. That's also another aspect of it. Wind has way too much variability, meaning your giant wind farm could be drop as low as 60 and as high as 6,000. So that variability is too much. Solar, on the other hand, is kind of predictable. It's like, yeah, we kind of get it. And if you add weather models to it, it's like, dude, we know this much power is going to come out of it. We know it's not going to do anything at the night. We know this is how it's going to work. So it's a known system, and people like known system because you can, again, if you're dealing with a residential system, you can have battery banks. It's like, I know what kind of power output I'm going to get. I'm going to add this sort of battery bank and I'm done for this. But we have to make a change because right now our solar power comes in, cooks the panel, we get electricity out of it. But again, that cooking the panel is going higher because again, temperature is getting hot. China's recent heat wave had atmosphere temperature, meaning the air itself was 55 degrees Celsius hot. These sort of solar farms will not produce too much energy again, they will work, but they will not produce too much because again, it will overheat. And all the panels are rated for 25 degrees Celsius and they easily reach to 60 to 80 degrees Celsius or even 100 degrees Celsius. And you're like, 100 degrees Celsius? Yeah, that's the whole point. It's a black square in the sun. It's almost like a giant thermal heater. So somebody had the idea, what if we take thermal energy out of it? That increases your electricity output. Why? Because again, temperatures is directly correlating to the power output of the cells. Cooler the cell, more energy you're gonna get. Same amount of lumens, exact same amount of sun. If you have two panels, one panel is actively cooled, you're gonna get more energy out of it. How much more? 5 to 10 watts, 10 watts I'm saying, 10% more. Or sometimes even like some cells are like really good responding to heat, they can give you around 20% more. And not to mention, longevity grows up exponentially, meaning your power drop over year would be very low. So what do you do with thermal energy? That's up to you. In winter, in European scenario, they worry about winter. That's a good way of taking care of winter. In India, I genuinely don't know what we're going to do with that. But again, some engineers could figure out, but we have to do it. Otherwise, our farm output, peak daytime will be not that amazing. So we have to move into those sort of hybrid scenarios so we can handle brutal heat wave that are coming in the future. So that's something we have to do. Now, thermal can be just used for the, again, whatever you want to do with it, or it can be just used for cooling PVs. There are some people who are creating thermal packs that will basically absorb the heat during the daytime and release the heat during nighttime. Now, that means the panel's average temperature would be constant. It will not go through thermal cycling of heating in the sun, cooling in the night. That will not happen. It will just remain at constant temperature. Again, that's a low cost alternative to having actually liquid cooling it. But again, each of them has pros and cons, but we have to do it. We have to do it for getting more oomph out of it. But again, even though solar can take care of majority of the situation and is starting to, like, brick by brick, the percentage of solar growing in the grid, we still have to add grid scale batteries in order to take care of a nation. Now, what about wind? Now, wind is something that is very successful in Europe, but again, sometimes it's not predictable. It's going to play a very big role in the future because it's one of those technologies that's finally reaching maturity, and people realize nobody wants wind turbine next to them because it's very noisy, it looks ugly, it has like blah, blah, blah. Nobody wants to have it. Like, people want to just put it out of sight, out of mind. Where is the best place? Offshore. Now, offshore does have this consequence of being expensive, but because of the economy of scale, meaning more and more people are doing it, it does allow offshore farms to be far more cost effective. Now it's like, how the heck this could become more cost effective? Because there is no size limit. If you are making things on land, there are serious size limitation, because even if you can make it huge, how the heck you gonna transport it? But on sea you can have huge things, meaning the turbines that are next to the seasides, they are huge, as in like Eiffel Tower is small compared to it, kind of huge, like idiotically huge. Those things cannot be transported inland. Like, good luck finding a system where you can transport those sort of things. So sea does allow you to have fewer turbines but larger turbines, and your maintenance is directly proportional to how many turbines you have. So instead of having, like, let's say many small turbines versus having few big ones will have better maintenance cost. That's why government and countries and companies are working their ass off to make huge turbines. Right now there are turbines that are exceeding 10 megawatt on turbine. Like, there are many turbines that are reaching 12 or even 15 megawatts. So it's going to play a very big role in the future, whether you like it or not. Now, consequence, it does have high capital cost, meaning it's going to take us some deep pockets in order to. It's not something Sri Lanka can do. It's not something that even India is truly doing at this point. Again, we have some pilot projects, some small things here and there, but it's not on large scale, not on like how big Europe is doing. And again, that's why Denmark is in such a good position. And again, Europe does have a roadmap. If the current rate of growth is expanded by like 2x or 3x, they'll be like, we are sorted, bro. It does have maintenance, that's one of the side effects, but does allow power 24/7 mostly. Meaning, again, it does have its own mood. You could have a scenario where you have to shut down turbines. Like, why? Well, if let's say plant capacity, rated capacity is 2 gigawatt, it's producing 1 gigawatt, but let's say wind started to go up, it started to reach that 2 gigawatt capacity, but no demand on the grid exists, you have to shut down turbines, which we call power curtailment. So it does have variability. Now, this variability is an issue in normal times, but in future, it will be a very good thing, because this amount of energy would be absorbed by energy storage system, whatever it may be it cryogenic air storage system, be it CO2 battery, be it pumped hydro or closed loop pumped hydro, whatever have you. Something will absorb that energy. That means there has to be surplus energy to absorb. Wind is the best candidate for, because it has its own mode, and generally it keeps overproducing when we don't want it to. But all things considered, wind is one of those things that are slowly going. But one aspect of wind is not sorted, is that what the hell you gonna do end of life? Meaning, how the heck we gonna dispose this? These are composite material, meaning they do not decompose. That's a very big issue. We have not sorted that part yet. So this was my presentation on like future of energy generation. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.